welcome back to another fabulous video by Firestarter Graphics and Engineering. Today we're going to do something really cool. We're going to make our own cloud server using SSH, PuTTY, Bitvise, and for those who want to do something kind of cool, SFTP NetDrive. So first and foremost, I want to give a shout out to renderforce.com for making that really cool intro for me. It takes about 2 minutes to make it and it's free. You just go to their website, pick the text, a picture, the music, and let them render it for you, and it's done. It's free, but you can buy commercial versions as well, so I highly recommend them. Alright, moving forward. Materials needed. You do not need to be an expert to do this. If you can browse YouTube, browse the internet, install software in your Windows machine, you're good to go. Does not require a whole lot of information to do this. You just need to be able to understand basic security principles that I'm going to teach in this first part. Now, if you already know these things, you can skip part 1 and move to part 2 of the series and above. But if you're new to this, I highly suggest the slideshow. It's somewhat informative, hopefully not too dry. Alright, you're going to need a laptop or a PC. The laptop or the PC is going to be used as a dedicated server, so it's going to stay at home or wherever you're going to put it. It needs to have a constant internet connection, and if you're asleep you can turn it off, but just be sure to turn it back on when you're awake, and you should be good. You'll need to have internet on it constantly, and make sure you have enough hard drive space for whatever you're storing. So I've used a laptop before, had 2 hard drives in it, worked great. I've also used a USB external drive as the storage source. It's a little bit slower, but it still works. I use a PC now as my dedicated server, and it's just a basic, cheap, I've used cheap computers before. Mine right now isn't cheap, but I've used cheap computers before, and it works great. So, you're going to need to download few pieces of software. You need to download Bitvise Server and Bitvise Portable Client. This is the thingy that connects you to your server from any PC out there in the world. If you're at a university, if you're at a library and using a public computer, or if you're even using your own laptop that you're traveling with. So, you just Google Bitvise Server and Bitvise Portable Client, and you can download those. If you don't want to use the Bitvise client, you can use WinSCP, but I still recommend Bitvise because I like it when you open it up. It says remote files and local files, so you know where things are at. You'll need a USB drive. It can be pretty small, 128 megabytes. Yeah, that small, 128 megabytes. You don't need a lot to run the client. You need to download something called PuTTyGen, and this is a public and private key generator. We'll talk more about that. And if you want to use SFTP NetDrive, go ahead and download that. What that does is it's going to allow you to, when you take your laptop out in the world and you install SFTP NetDrive, basically it installs a virtual hard drive on your laptop that makes it look like it's a hard drive on your computer, and when you click on it, it's actually really connecting to your server. So it becomes like a virtual hard drive. Not going to go into all the theory of how it works, but it is fascinating. Then you need to be able to have access to your home router so that we can punch a hole in the firewall to allow access into the server. Then for those wanting even more of a challenge, try using a Raspberry Pi as the SSH server. Alright, so what's our objectives? We're going to go over what is the cloud, different methods of file storage, how this works, installing, then security, and then integrating with SFTP NetDrive. So, what is the cloud? You keep hearing this word. Have you saved it to the cloud? Are you part of the cloud? La-di-da-di-da-di-da. Yeah, if you've had the internet, you're part of the cloud. The cloud is just a fancy word for the internet. Back in the day, early 60s, when they first started coming out with packet switching, and they came up with network drawings and diagrams, instead of drawing all the routers and switches out in the that go across what they call the wide area network, instead of drawing all the routers and switches, they just drew a little cloud and saying, there's stuff that lives in this. But don't worry, it looks just like your private network. It's just more expansive. So you have a home router at home that connects to your ISP. Imagine that on a bigger scale, like the size of a closet, and it lives inside this, and it's just passing data along from one network to another. That's all the cloud does. That's all the internet is just a bunch of networks hooked together. So let's just zoom in a little bit. Okay, look, see, yeah. If this is a computer inside the cloud, such as you at home wanting to connect over here, it may choose to go this way, but if this line is being a lot of data and there's something going on, it may take this route. Coming down here, coming up here. And it may look like the longest route, but it's probably the shortest path and the fastest. So that's all the cloud looks like on the inside. See, your provider network, your ISP lives in here. And it just passes data along. That's all the cloud is. So when someone says, are you saving, I just saved my data to the cloud. All that means is you are over here and you've sent a file to another private network on this side of the cloud, maybe Google or Dropbox, and you just saved it on their computer. No different. It's no different than what we're going to do in this series. Now, it's okay to do online storage. Really is. But I like having everything on my computer, mainly because, yes, I do have to maintain it, which is not hard. It's making sure I replace the drives every 10 years or 5 years or 2 years or however long. But my data's there. No one can snoop at the data. Sometimes if you read the terms and policies and agreements with these online providers, they do have the ability to look at what you're saving. So if you're concerned about privacy, building a cloud server at home is the way to go. Okay, so let's talk about the different types of protocols used for transferring files over the internet. The original one was called, or one of the originals was called FTP, and it lives at port 21. So let's talk about this port. FTP is File Transfer Protocol. Everything is sent in clear text. Your username and password is sent in clear text. Anyone who's sniffing on the wire can see it. But what is port 21, you ask? I'm really glad you asked that question. What that is every computer has an IP address. That's like an address of an apartment complex. So your friend says, hey, I live at 123 Fake Street. You show up there, it's a big complex. You text them and say, what door number are you? Oh, I'm door number 21. So you go up, knock on the door, shake hands, initiate communication, and then do whatever you need to do. That is exactly how a computer works in a server-client situation. Client sends data, goes through the cloud, gets to the apartment complex, which is the server, and it looks at its envelope of data, and inside there's a piece of information that says, I need to go to door number 21. So it goes to door number 21, knocks, and does something called three-way handshake, where communication is initiated, and it takes your file and saves it there, door number 21. But like I said, it's unsecure. Username and password is sent over in clear text. So FTPS is the secure version of that. It's a little bit trickier to set up. I'm not a big fan of it, but you can do it. Other ways are VPNs. And originally VPN was to create a encrypted tunnel for someone who's not at the office. Maybe they're traveling for business. And what it does is it allows them to become part of the private network at their office and be able to access files. That's what it originally was made for. But you can send internet data through it. So, but Hamachi is a really easy system to use. Download it, install it, create a network, put a password, have a friend or a family member install it, have them join the same network you created, give them the password, and you'll see on your screen that, hey, I have these 5 people in my network. If you right-click on one of them and hit Browse, anything that they've shared locally, you can now see, because guess what? You're part of their network. It's really pretty cool. But we're going to be using something called SSH, and it lives on port 22 or door number 22. We're going to use FTP over SSH, which is File Transfer Protocol, over the secure shell. And it's basically SCP is secure copy. It's kind of secure copy on steroids. You can copy multiple files, not fires, files over at once using the FTP protocol over the secure channel. And what SSH does is actually creates an encrypted tunnel from the client to the server. And you can do copy, paste, send files over. You can even use Bitwise client, which you've downloaded and you're going to be installing, and you can actually use that to send internet traffic through this encrypted tunnel. So you can sit at McDonald's or Starbucks and browse the internet with an encrypted tunnel. It's actually really cool. People can't sniff your data. It's really nice. So, and it's simple to set up. Anyways, so that's what we're going to be using is SSH, Secure Shell. If you're curious about what it exactly is, go ahead and research it. Okay, so here's how it works with a TCP connection. Computer A, which is the client, wants to talk to the server, so it sends a synchronization. I'm just going to call it data for right now. You guys don't need to know the difference between bits, packets, frames, segments, and all that. But if you're curious, go look up the OSI model. Anyway, so it's going to send some data called the synchronization data, and the server's going to say, it's going to receive it and say, hey, I'm going to send mine now, and an acknowledgement that I received yours. So it receives the synchronization bit or data, and then acknowledges that it's received it, and then a connection is established, and that's the three-way handshake. And now authentication can happen, and you can send data. So that's it in a nutshell. If you're curious about this, go look up three-way handshake and sliding windows. It's really cool. TCP stands for Transmission Control Protocol, which means if an error happens in the line, sliding windows will backtrack a little bit so that it will resend the packet that dropped. It's connection oriented. It wants to make sure that data is sent in order. Video streaming is UDP, and that's why it glitches, because data just falls out, and it's not worrying about, well, I'm not gonna go back and find that lost bit of data in the music or the video. Okay, next, this is the most important part of this video, the cryptography part. We're going to be using something called a Diffie-Hellman key exchange. They're really easy to create. There's literally no work, maybe about 30 seconds of work to do this. No math involved. For the user, there's no math involved, but behind the scenes, there's a lot of math involved. And how it works is I come up with two prime numbers. I tell you what they are, so I'm the client, and I tell the server what they are. You then pick a secret number, but you don't tell anyone, and you compute some other number using a g to the exponent of a, which is the number you came up with, the secret number, and then you modulate it, and then multiply it by p, so it's an algorithm, and then you send that result back to me. I do the same thing. I don't tell you what my secret number is, though, even though we shared two prime numbers with each other, but I don't tell you what the secret number is. Then I compute that secret result, then we send each other those results, then do the exact same operation that we did before, and the magic happens that it will automate for some reason. They're inverses in math, and they'll undo each other, and we'll know the secret numbers without anyone across the line seeing what they are. It's actually really kind of cool. You can look it up if you want more information. So password strength, let's talk about that. Basically, how passwords work is, let's just go with an 8-character password. If we just use 26 letters in the alphabet, uppercase and lowercase, that's 52 options. So you take however many characters you want your password to be and raise it to the power of 52, and that'll tell you your possibilities. But there's really actually 94 possibilities: uppercase, lowercase, numbers, and special characters. So you can get large amount of possibilities. I think it's like 7.7 times 10 to the 84th. It's a large number of possibilities of passwords. Just when you make a password for email, we're not going to use password for this. I've decided not to even go there. But if you make password for email, make sure that you don't put a word in front of special characters. A dictionary tag can break that. Might take a few days, but it can happen. Okay, so here's kind of a picture of how the key exchange works. You can go over this. If you know math, great. I've spent a lot of time with math, 13 semesters to be exact. That's what I do. Mechanical engineering is a great field. I'm not trying to push that, but I love it. So that's just kind of my history. I was a network engineer for many years, and then I decided to go into mechanical engineering. So I still do both. Companies love that I can do both, so it's great. Anyway, I think the time has come forth. Is that even the right way to use that word? The time has come to move forward and build our server. So it's not going to look like this. Remember I said it's on the laptop or regular desktop PC. It can be like this, but for what we need, this is like complete overkill. This is like a commercial type of setting. Anyways, perfect. Thank you for watching. Stay tuned for part 2, part 3, part 4, 5, maybe 6, maybe just part 2 and 3. I don't know how many parts it's going to take, but you can skip part 1 if you know all this information and move right into part 2. So, let's get busy.